Okay, I'm going to go through two problems in the stoichiometry worksheet with you guys. The key is setting up this BCA table. So, number one, hydrogen sulfide gas, which smells like rotten eggs, burns in air to produce sulfur dioxide and water. How many moles of oxygen gas would be needed to completely burn 8 moles of hydrogen sulfide? So, we've got 8 moles of hydrogen sulfide. We have no products. We're going to need to figure out how many moles of oxygen is actually reacting with 8 moles of hydrogen sulfide. And to do that, we can ask ourselves, well, 3 moles of oxygen react with 2 moles of hydrogen sulfide. So I'm going to set up a fraction, or a ratio, 3/2, and I'm going to times that by 8. It's a top-heavy fraction because I know the oxygen is going to be greater than the hydrogen sulfide. I can do that in my head. 3/2 times 8 is going to be 12 moles. So I know this is going to be 12 moles. Now we've already figured out our answer, but I'm going to go ahead and fill in the rest of the table because it gives us a good overview of the problem, and any question about this table could be asked. So our 8 moles of hydrogen sulfide is going to be used up. I'm going to let that be a minus. Our 12 moles of oxygen is going to be used up. That's going to be a minus. So we're going to have nothing left in the end. If we look at the change side, I've got 2 moles of SO2 and 2 moles of H2O. And I had 2 moles of H2S on the left. And since the mole ratios are exactly the same, these are all going to be 8. 8 moles. But we're going to add 8 moles. We're going to add 8 moles because we're forming them, and at the end we're going to have 8 moles and 8 moles. So, how many moles of oxygen gas would be needed? Our answer is 12, but the rest of the table gives us a good idea of what's going on with the problem. Okay, let's look at the next one. Propane, C3H8, burns in air to form carbon dioxide and water. If 12 moles of carbon dioxide are formed, how many moles of propane were burned? So now we are given some information about something being formed, the carbon dioxide. So let's go to the end. We're going to put 12 moles, that's going to be formed. And to figure out how much water is going to be formed, because again I want to fill in the whole table, I'm going to set up a fraction. And I'm going to say 4/3 and times that by 12. And the reason I chose 4/3, a top-heavy fraction, is because I knew that the water has to be greater than the carbon dioxide because I've got 4 moles compared with 3 moles. So let's just figure that. 3 into 3 goes once, 3 into 12 goes 4 times, so my answer is going to be 16 moles. And now I'm just going to work backwards. That's going to be plus 12 moles. This is going to be plus 16 moles. We have nothing to start with. At the end, this is all going to be used up. So if we look at the change side, my CH3 is a 1 to 4 mole ratio with H2O. So this is going to have to be 4 moles. Let me show that again. There's an imaginary 1 over here, and there's a 4 over there, so it's a 1 to 4 ratio, so that has to be 4 moles. My oxygen is 5 times as much as that, so that's going to be 20 moles. Again, I'm looking at the mole ratio, and those were used up, so I must have had my 4 moles to start and 20 moles of oxygen to start. So the question says, how many moles of propane were burned? We can go back to the beginning of our chart and say 4 moles. 4 moles of propane were burned, but we needed to fill in the whole chart just to get a good understanding of that whole problem. And I hope this helps for you to I hope this helps you finish the rest of the worksheet. So you've got another 3, 4, got another 4 problems to do. Alright, good luck. One more thing, when you set up a BCA table, make sure that you put the equation at the top, okay, and that you've got these columns available underneath each of your reactants and each of your products. But the equation has to be something you got to write down, otherwise you won't know what sort of reaction the table is describing.